There weren't, in the particular test, this 2012 practice test, there weren't that many questions that were just like Chapter 4 things. Chapter 4 stuff does continue to show up in all the subsequent chapters, so we'll see some more there. But this particular page, it's just these four. 1, 2, 3, 4, 5. Just kidding, 5 problems. So let's do them. If f of x is equal to this, then what's f prime of 1? All right, well, let's find f prime of x. The derivative of 7x is 7. The derivative of minus 3 is 0. And the derivative of natural log x is 1 over x. And you want to plug 1 into this, you get 7 plus 1 over 1. Which is 8. Boy, if you know some just very basic stuff about derivatives, that is a softball right there. All right. There's really two ways to look at this number 14. You can look at it as a L'Hopital's rule problem, or you can look at it as a definition of the derivative problem. If this looks familiar, like h approaching 0, x plus h, you can do it that way, or with L'Hopital's rule. If you're like, wait, L'Hopital's rule works for like f of x, what about this h thing? H is just the name of a variable, so you know, if it makes you happy, you could just rewrite those as x's and use L'Hopital. So that's what I'm going to do first here, because I put it in Chapter 4, thinking about L'Hopital. So L'Hopital's rule says if you plug the 0 in, so let's see, if I plug 0 in here, it'd be natural log 4 minus natural log 4 over, so 0 over 0. That's when we can use L'Hopital's rule, for 0 over 0 or infinity over infinity. So what does L'Hopital's rule say? L'Hopital says that if you have a limit and it's 0 over 0 or infinity over infinity, then you can just take the derivative of the top. Let's see, the derivative of natural log of 4 plus h, derivative of natural log of whatever is 1 over whatever, times the derivative of what's inside, well, that's 0, and h is like the variable. We're pretending that's like x, so the derivative, that's just 1. So the derivative of natural log 4 plus h is just 1 over 4 plus h. Minus the derivative of natural log 4 is just a number, so it would be a big mistake to put 1/4 here, because natural log 4 is a number, and when you take the derivative of a number, you get 0. And then the derivative of that is 1. And then we have resolved the 0 over 0 problem, so now you can plug in h equals 0 and you get 1/4 over 1, or just 1/4. The other way to do that is to look at this and say, hey, I just studied my calculus notes, and I remember that the definition of the derivative, f prime of x, is equal to the limit as h approaches 0, f of x plus h minus f of x over h. And this looks like one of these. So, okay, is it? Yes. So what's the x value? The x is 4. What's the function? The function is natural log x. The function isn't natural log 4. The function is natural log x, and the x is 4. So that's an important thing to understand. So if you were looking at this, f of x is natural log 4, and I'm interested in at x equals 4, and you tried to write the definition of the derivative, this is exactly what you would get. And if you recognize that, then you're like, oh, that's just f prime of x. So what's f prime? What's the derivative of natural log x? It's just 1 over x. And then what do you get when you plug 4 into that? You get 1/4. So those are the two different ways to do that. Number 15. So I've got this function, f of x, and g is the inverse function of f. Given that f of 0 equals 1, what's the value of g prime of 1? So this is one of those. We did a sheet. I pushed something out to you that was a bunch of problems like this, where if I know that on the f function, if on the f function there's a point 0, 1, and g is the inverse of that, then that means the point 1, 0 is on the inverse. And if I know the slopes of these two at these two related points on the function and its inverse, those slopes are upside down of each other. This is in the notes, I think, 4.3 part 2, I think, if you want to go back and look at those notes again. It's 4.3 part 1 or 2. I'm pretty sure it's 2. Okay, so what I need to do is, if I can find, like, after doing a little bit of work, if I can find f prime of 0, then here g prime of 1 is equal to the upside down of this. I just have to find that and then flip it over. If you were a betting person looking at these different answers, I'm not going to pick an answer based on this, but these two, if you remember that relationship about the upside downness of these, then here's a number and the same number upside down. So that makes me feel like, you know, they probably would have wanted to put the person who forgot to flip it over. So I'm kind of feeling like it might end up being one of those, but of course I'm going to do the problem anyway. So I need to find f prime of x, the derivative of this. What's the derivative of this? It's 3. What's the derivative of something cubed? It's 3 times that something squared times the derivative of what's inside, which is 2. So what's f prime of 0? If I plug 0 in here, I get 0 plus 1 is 1, squared is still 1, times 3 times 2 is 6. So if f prime of 0 is 6, then g prime of 1 is 1/6. Right, that's what we know about functions and their inverses. If you look at those related points, here's the xy, here's the yx, then the slopes are upside down of each other, because rise over run flips over. And sure enough, hunch of person who's been teaching calculus for 20 years was correct. Go figure. So if x plus 2y times dy dx is equal to this, then what's the value of that at the point 3, 0? All right. So I need to take the derivative of this. This is like section 4.1. This is like implicit differentiation. I'm going to move down here to do that. So different ways to do this. I guess I'm just going to leave it here. You could like try to, if you wanted the dy dx to be on one side by itself, you could divide this over here. That's an option, and then do the quotient rule. But just in case you didn't think about doing that, I think I'm just going to leave it. Now this is a product, so I do need to do the product rule. So x, the derivative of the first is 1 plus 2 dy dx. That's the derivative of the first. Remember, every time we take the derivative of a y, one of those pops up. So the derivative of the first times the second plus the first times the derivative of the second. And the derivative of the derivative, that's the second derivative. So that's where this pops up. So there's product rule on that. That is equal to the derivative of 2x is 2, minus the derivative of y is just dy dx. Okay, so I want to find the second derivative, at the point 3, 0. Now the problem is, so I can plug in the 3 for x and the 0 for y. That's all great. But I've got these dy dx's. What's that equal to? Well, I've got this, right? So if I plug 3 and 0 into this, that's going to tell me what dy dx is equal to at this point. So let's do that. If I plug 3 in for x and 0 in for y, I get 3 times dy dx equals, if I plug 3 in for x and 0 in for y, that's 6. So dy dx at this point, sometimes you can, if you want to do that notation, I could just say this for our purposes here, but if you wanted to indicate that this is, dy dx isn't equal to 2 all the time, it's just equal to 2 at this point. So if you wanted to indicate that, you can do this. You do like a bar, and then like down here, which is just to say, like I'm plugging in, like dy dx at this point is equal to 2. So whatever, that's the thing we're going to plug in for these. It's just a notation thing. Okay, so what do I know? I know that x is 3, y is 0, and dy dx is 2. So I got 1 plus 2 times dy dx times dy dx plus x is 3 plus 2 times y is 0, so that's gone, times the second derivative, which I don't know, that's what I'm looking for. Sorry, I do know that that's what I'm looking for, but I don't know it, and that's what I'm looking for. Minus dy dx is 2. All right, so let's see. This is 5 times 2 is 10, plus 3 times the second derivative is equal to 0. So subtract that over and divide by 3. It looks like my second derivative at the point 3, 0 is going to be negative 10 thirds. And the last one, looks like I need my calculator. Let me grab my TI-84, because that's probably what you're using. If you're going to take the AP test, there are 2 sections where the calculator is, that are called calculator active. And within those sections, you don't necessarily need the calculator for all the parts, but if you just kind of scan the answers and you see answers like this, like obviously we're not going to do this kind of thing by hand. This is a calculator problem. I got a trig function here, so right off the bat, before I do anything, I'm going to go to mode and make sure that I'm in radian mode, which I am not. So that will get you in big trouble. When you're in calculus, you're in radian mode. So always check to be safe. So the graph of this crosses the x-axis at one point in the interval from 0 to 1. So let's go ahead and just graph that. Y equals e to the, you know, you have an e to the button right here. If you do second natural log, it's e to the tangent x, e to the tangent x minus 2. Now I could just hit graph and see what happens, but I know that I'm only interested in the interval from 0 to 1, so why would I want to look at anything else? That could be potentially confusing. So I'm going to make my x min and max 0 to 1. The rest of this is probably fine. I only care about where it crosses the x-axis. So let's see what it looks like. There's the spot where it crosses. And what do we want to know? We want to know what's the slope at that point. So I need to find the slope at this point right here. So how do we find that point? Second, calculate. I want to find where it crosses. That's the 0. And it crosses somewhere between here. Since they put the cursor, it was kind of close. I'll just play this game. So that's where it crosses. Now I bet that's one of the answers. So this is the sucker answer right here. That's where it crosses the x-axis. That's not the slope. So don't pick that. That's just for the person who's like, oh, I just saw that number in my calculator. Sweet. No, that's not the answer. We want to know what the slope is here. So I'm going to go back into my second calculate menu because people who made this calculator knew that someday I was going to do calculus with it. So dy dx, that's option number 6. And the thing that it automatically goes to is the last x value you were thinking about. So I'm just going to hit enter because it's got the right x value in there. And then it tells me that the slope right there is 2.963. Oh, 2.961. So the calculator, when it does this, it approximates things by number crunching. So I'm going to be pretty confident that this is just like a calculator error and that it's not anything that I did wrong. All right.